Let's start with some activities for beginners. When we say beginners in this course, we mean children who know the numbers until 10, but who are just beginning to learn operations such as adding and subtracting. So I recommend starting with strings of bits. On this we can count the separate units. With a rod like this one, it is not quite obvious that it represents 5. But on this string I can count 1, 2, 3, 4, 5. We can join two strings and ask, can you find a string which is as long as these two together? We can do this several times with different strings, but don't let the sums be greater than 10. Then we can count them. First separately, 1, 2, there are 2. 1, 2, 3, 4, there are 4. Now together, 1, 2, 3, 4, 5, 6. Together there are 6. So we can say 2 plus 4 are 6. We can do the same with objects of everyday life. 2 potatoes plus 4 potatoes are 6 potatoes. 2 dishes plus 4 dishes are 6 dishes. So the child experiences that 2 plus 4 are always 6, no matter the objects we are using. In other words, number is a quality independent of other qualities such as size, color, shape, taste, or whatever. To you this may be obvious, but for the child it is an important step in the development of mathematical thinking. It is almost a philosophical or spiritual discovery. By this experience, a child may sense for the first time that there is a world beyond our visible world. We experience that numbers have an existence of their own. They do not depend on any material object in this world. They belong to an invisible world of abstract truths. On a more practical level, our children need this experience to avoid what happened to Bobby when his mother asked him, "How many are 2 oranges plus 4 oranges?" And Bobby replied, "I don't know. At school we always calculate with apples." Okay, we do the same with Cuisenaire rods, and we find, of course, that here also 2 plus 4 are 6. Do some more examples, and then we can begin with the steps towards abstraction and written symbols. In the first video, we have already seen how this can be done. Now, an important principle for addition is the commutative law. This means that we can change the order of summands and the result stays the same. With our strings and rods, this is obvious. When children understand this with small numbers, they will also be able to apply it later to larger numbers. The commutative law can save us some work. Let's say we add 1 plus 7. If we don't know the result already, we have to count. 1, 2, 3, 4, 5, 6, 7, 8. But the commutative law allows us to see that this is the same as 7 plus 1. Here we don't need to count so much. 7, 8. There we are. This is an example of how operations can be compressed mentally. We talked about this in the introductory course. Let's do some examples like this one with the children. Until now, we proposed the calculations. But the children can invent their own addition problems. First, you can let them do whatever additions they wish. Then we can establish some conditions. For example, find numbers which add 8. We can visualize them with this house of 8. Fill it with rods, but without repeating any combination. Then we can write down the sums we have formed. Some children will do it in any arbitrary way. Others may do it in a very orderly way. This kind of stairway contains all possible combinations with 2 summands. Now, at some moment, we should introduce sums with 0. I can say that this rod of 8 also represents a sum, 8 plus 0, or 0 plus 8. We can imagine the 0 on any side, since a zero rod does not occupy any space. With activities like these, we encourage the children's creativity. They can invent their own challenges. Some children may need help to expand their horizon. For example, why should we always add only 2 numbers? Here we have another house of 8, but with sums of 3 and more summons. In the same way, we can construct a house of 9 or of 10. With 10, it will be useful to know by heart the combinations of 2 summons. Later we will use some operations where it is good to know the tens complements. Well, these activities can be described in a few minutes, but for actually doing them with the children takes sufficient time. We want them to understand what they are doing. If they do it for the first time, 1 week may not be enough for all of this. And now I have a challenge for you as an adult, or also for older students. These sums, as simple as they look, are hiding some mysteries which are not as easy to unlock. This is the question. We want to build a complete house of 10, a house which contains all the possible sums which add up to 10. How many floors will this house have? And how do we know that we found all of them? Now we have to define first which combinations we count as different. For example, here I have a sum, 2 plus 3 plus 5 are 10. Here is another one, 3 plus 2 plus 5 are 10. And here another one, 5 plus 3 plus 2 are 10. But these are the same rods, only in different order. Remember the commutative law. So, do we count these as different combinations? Or do we say they are repetitions of the same sum? According to the answer we give, we will have 2 different problems. Let's investigate both of them. How many floors has a complete house of 10 if the order of summons does not matter? In other words, if we take away these 2 sums as repetitions of the first one. And how many floors has a complete house of 10 if the order of summons is important? In other words, if we consider these as 3 different sums. And for both cases, how do we know that we found all the possible combinations? I can already hint that the 2 problems are quite different mathematically. So, if you found a way to solve one of them, it would not necessarily be a good idea to try exactly the same approach for the other problem. Their mathematical properties are rather different. Now it's your turn. Share your ideas in the discussion forum. But please don't just say, "This is the answer." Share how you found your answer and why you think it is correct. Share also your doubts and questions.